Okay. Hello and good morning, everyone. Welcome to Epsilon 2021. I am Anagha, co-treasurer at IEEE SIESGST.
Hi, I'm Harshita, MDO at IEEE SIESGST. We are honored to be your hosts for this session. IEEE SIESGST's Epsilon 2021 is a brand new initiative with a prime focus of imparting technical knowledge revolving around the theme of computing and knowledge engineering.
We hope you will gain a great deal of knowledge and learn a lot of new concepts from the first upcoming session for the day, which is an introductory session on machine learning or artificial intelligence. And now, for the first talk session of the day, we have under IEEE Track of event an introductory session named AL the Ultimatum.
Wow, it sounds good.
Absolutely. Now let us begin with our most awaited session by welcoming our first guest speaker for the day.
We have with us Ms. Lois Anne Leal, who is a science research specialist and a volunteer machine learning engineer working on artificial intelligence focused on computer vision. Her main goal is to contribute to the advancements in the intersection of space technologies and artificial intelligence. She also enjoys lifting up others who are in this field and advocating the use of artificial intelligence for impact.
Yes, ma'am, we are really excited and grateful to have you with us today, and we are looking forward to this very amazing session. Also, just a little information for the attendees. This session will go on for 90 minutes before the quiz session. We will be sending you the link for the quiz in the chat box during the last 30 minutes of the session. This quiz will earn you badges at the end of the event, and if you land yourself in one of the best performance, you also can stand in chancing, and you can also win goodies and exciting goodies in the end of the session.
So, without any further ado, I would like Ms. Lois Anne Leal to begin the session by throwing light on ML and its history and guide our participants through the vast world of artificial intelligence.
Hi, everyone. Am I live now? I think
Hello, ma'am.
it's a real pressure. It's a real pleasure for me to be speaking in this conference. It's really, I'm really excited and thrilled to be speaking to you today. So I think without further ado, I think we can start it now.
Yes, ma'am.
So when will start?
Okay.
So we'll be starting now, any minute.
Yeah.
Okay, I think my screen is now out.
Yes,
Okay.
yes, ma'am.
Okay, thank you so much for that very generous introduction. And
Uh-huh.
yes, the title of my talk will be AI and ML, the Ultimatum. So I tried to position this talk, I created this talk as if my younger self would be watching it also. So I'm really excited to be sharing to you about this field that I'm very passionate about. So just as they introduced me, I'm Lois Anne Leal. You can call me Lois, and I'm currently working as a science research specialist under the Philippine Space Agency, and I'm working there on computer vision and AI projects. In my available time, also, I volunteer as a machine learning engineer at Undina. So Undina, they work on high AI impact projects, and I'm working there with all AI ML engineers all over the world. So that's pretty exciting too. So in my talk today, the title is AI and ML, the Ultimatum. But here, I want to talk first about the first part, which is AI and ML. And for us to have a common ground of things, I think it would be nice to start it with the definition of AI. So AI, according to IBM, it enables computers and machines to mimic the perception, learning, or problem solving and decision making capabilities of the human mind. And I think the keyword there would be mimic. It's inspired by it, it's not exactly it, but it's mimicking it. And I think nowadays you can see AI in your Twitter feeds, in your Facebook feeds, or your friends are talking about it. And yes, according to the pioneer and maybe your go-to instructor when you're beginning, Andrew Nung, he said that AI is the new electricity. So just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. And Andrew was right. I mean, it's not in the future because it's currently happening right now. And you see that AI is practically everywhere. When you wake up in the morning, you search something in Google, you're interacting with an AI. As you can see in the Google icons, you can search using your pictures, you can search using your voice. And then here you have old pictures coming to life. Of course, in Amazon, it's also there in their bots, in their warehouses. And maybe when you're buying stuff, they are also recommending things to you. And when you open your Android phone, you're also talking to one of the Google AI assistants. And of course, you have your Snapchats for people who like posting their selfies and the Tesla's capability for self-driving and many, many more. In the art industry, it's there. In the Go competitions, it's there. And it's really doing that good. And maybe if you're playing Dota, I think you've heard of the Dota competitions versus an AI, and you have it on your sciences. I think these are the recent events. We have the black hole image, we have the Mars rover, which really takes up our news feeds. And of course, it's also used in Earth observation. So these are just instances, but you can see AI is practically everywhere. And next, also in the media, of course, we can have Wally, inspired AI, and Ex Machina, the YouTube originals. And if you're a fan of K dramas, Korean dramas, I think you've heard of this recent drama called Startup, where they exposed speech recognition. Also, we have computer vision in the side. So AI is practically everywhere. Maybe you didn't know it at this time, but you're using it and you're interacting with it even every single day. So AI is everywhere, and it's here to stay. It's not going anywhere soon, but it's here to stay. So that leads me to the second part of the discussion, which is why is it an ultimatum? Why is AI and ML the ultimatum? Well, what is ultimatum? Ultimatum is a final proposition. It's a condition or demand, especially one whose rejection will end negotiations and cause a resort force or other direction. So that's kind of mouthful, right? But in short terms, AI is a very important technology, and as we see before, it's practically everywhere. And even if you're an ordinary person or you're choosing it as a career path, you're gonna be interacting with it, even if you're not aware of it, right? So it's a very important technology, and the responsibility of this talk for me is to not leave you uninformed about this technology, because there might be consequences of not knowing this technology while interacting with it and the other cases. So I think as we begin to look at this field, it would be nice to share my experience about it. How did I start with it? So if I'm going to use a metaphor of starting in I think my first step in AI is like my first time in the sea. You know, when you're starting with AI, it feels so dark there, and there are lots of stuff going on. You can see people in Twitter saying, oh, this is a convolutional neural network, that's a machine learning, that's deep learning, reinforcement learning. There's a lot of things down there. And though it's very interesting, but at the same time, it's like it feels kind of overwhelming. And that's how I started to when I first stepped in this field. But then as you go on, as you try to see what's in, as you recognize things and as you structure it, you kind of enjoy it. You can see, like, as my metaphor in going to the sea, you can see the corals, the beautiful corals. You can see the fishes, and you can enjoy it with your friends. And as you gain momentum and as you gain that confidence, you just really enjoy it. And I think that is one important thing, that even this is a technology field, you should also enjoy it. And that is one thing that I really want to emphasize. You should enjoy it, even uh, if you're doing it as a career path. So I will be starting the AI tour right here. And I'll be covering these topics. So I'll be covering in the beginning of AI, the history. Because of that, we'll have different algorithms. So it's fine to categorize it to different ML systems. And then we move to different types of data. Because as we know, data is one of the reasons why AI is booming right now, right? And of course, there's this related field called data science that is often confused with AI. And I will also show you the most common or the different roles in an AI team. And lastly, for the general audience, what or how are we going to position the humans in the world of AI? So that's the blueprint of the coexistence of humans and AI. So without further ado, let's start with the very beginning of AI. So where did it come from? I like to start it with this in the beginning of AI because it's very colorful, and AI has a very colorful history, and it just made me respect the field and be humble and to not take for granted the things that we have now. So AI is a vast field, and in this history, I can tell you more, and it's going to be long, but in this session, I will be focusing a little in AI and ML, but the focus of the history would be deep learning. And I think you've been hearing deep learning also a lot. And I will be discussing it by the key trends. So the the three waves of development, and then we'll move to the history and the amount of training data, and lastly, the computer infrastructure and the model sizes. So for the three waves of development, deep learning is rebranded as deep learning in our time, but before it's called, it has different names. The first one would be cybernetics. And as you can see, the use of cybernetics, the term of it, the term usage is, it peaked on 1970s, and for connectionism, it peaked in the mid 1990s, and now we have what we call deep learning. So looking at the first wave, it's called again cybernetics. It ranges from 1940s to 1960s. So it started with people, as you can see here in the definition. It's the scientific study of how information is communicated in the machines and pieces of electronic equipment in comparison with how information is communicated in the brain and nervous system. So in short, it's more of like a fusion. People in this time is like fusing the concepts or the ideas in brain and nervous system with the piece of electronic equipment. So it's very physical, it's very in electronic way. And to pick a starting point, it would be nice if we start with the 1943, the artificial neuron. And the folks responsible for this would be Walter Pitts, a neurophysiologist and cybernetician, and Warren McCulloch, who is a logician and cognitive psychologist. They have different affiliations, but at this time they've done this under the University of Illinois and Chicago. So what is this artificial neuron? As you can see, our artificial neuron is inspired by the biological neuron, as in our definition of cybernetics. So here in the left, you can see the live neurons, the biological ones. And here in the right, we can have its parts. It has those nucleus, we have the dendrites, we have the axons, and you can see in the axons, there are stuff lighting up, there are signals. So Walter Pitts and Warren McCulloch thought that it can be further simplified and use this as a inspiration. So here in the artificial neuron, the parts would be there are incoming inputs or there are incoming signals. And this is like the linear model that we know nowadays. So this linear model could recognize two different categories of input by testing whether the function in this part is positive or negative. So it's also outputting signals that could be positive or negative. The difference, though, here is that the weights are being set by the human operator. Then after that, after some years, we have the Turing test. Of course, Alan Turing would be a figure widely known in computer science and also here in AI. So the Turing test, to put it simply, there's an interrogator, and the interrogator's job is to see or to distinguish if he can tell the difference between the human and the machine. And it would be nice if the machine is indistinguishable from the human one. And then after a year of that, there will be the first neural network, but it's very different from the neural network that we know today because it's more, again, in electronics part. So this is called the SNARK, and it's made by undergraduate students. Yes, undergraduate students by Marvin Minsky, by the names of Marvin Minsky and Dean Edmonds. And after 5 years, it's as early as 1956, AI as a discipline was conceived. And Dartmouth College would be the official birthplace of AI as a field. And if you would ask me who coined first the term artificial intelligence, would be John McCarthy. So what happened is that it's a very interesting story. John McCarthy convinced Mac Minsky, Claude Shannon, which is also a very prominent personality in the other fields, and Nathaniel Rochester to help him bring together US researchers interested in automata theory, neural networks, and the study of artificial intelligence. And they organized this 2-month workshop at Dartmouth in the summer of 1956. And there are only 10 attendees overall. And I listed here the faces of the 10 attendees. So, the Dartmouth workshop made a lot of, it's a very historical moment. But in that case, it just doesn't lead to any breakthroughs yet, but it did introduce all these major figures to each other. And after some years, we have Frank Rosenblatt and the perceptron. I think the word perceptron would ring a bell because in most of the AI classes, the introductory ones, I think they would love to start with the perceptron. And the person who created it would be Frank Rosenblatt. So I have a video right here, and it will tell you more of what Rosenblatt perceptron is. I hope the audio is audible.
Guy, Frank Rosenblatt.
Rosenblatt, in the late 1950s, developed what he called a perceptron, and it was a neural network, a computing system that would mimic the brain.
The basic idea is a collection of small units called neurons. These are little computing units, but they're actually modeled on the way that the human brain does its computation. They take incoming data like we do from our senses, and they actually learn, so the neural net can learn to make decisions over time.
Rosenblatt's hope was that you could feed a neural network a bunch of data, like pictures of men and women, and it would eventually learn how to tell them apart, just like humans do. There was just one problem. It didn't work very well.
Rosenblatt, his neural network was a single layer of neurons, and it was limited in what it could do, extremely limited. And
okay, I think we can stop right there. So Frank Rosenblatt and the perceptron.
Guy, Frank Rosenblatt.
Frank Rosenblatt's perceptron, if we're going to relate it to what we have today, it's more related to the linear models because it only have one layer. So these models remain some of the most widely used machine learning models, though in many cases, they are trained in different ways than the original models were trained. And yes, Frank Rosenblatt's perceptrons have limitations. And it's in 1969, the field has its first dip, specifically in the popularity of the neural networks. So it has many limitations. As we know today, these linear models, the most famous proof for it is that it cannot learn the SOAR function. And the critics who observe these flaws in linear models cause a backlash against biologically inspired learning in general. But it's not that one-sided. In the same book, Marvin Minsky and Seymour Papert, in that same book, they also show that using multiple layers, that should ring a bell, using multiple layers of the devices would allow these limitations to be addressed. But unfortunately, only the first parts, which is about the limitations, those only were widely recognized. So as a result, the global academic community nearly entirely gave up on neural networks for the next 2 decades. So some people may call this the first AI winter. So in the first part, I think we can confuse it with the field computational neuroscience, but again, those fields are very different to each other. Computational neuroscience is primarily concerned with building more accurate models of how this brain actually works. Whereas in deep learning, we are concerned with how to build computer systems that are able to successfully solve tasks requiring intelligence. So, while some researchers cite neuroscience as an important source of information or inspiration, others are not concerned with neuroscience at all and are inspired by other fields like applied math fundamentals such as linear algebra, you have probability, you have information theory, or numerical optimization. And in the next wave of AI arose in the context of a different field called cognitive science. So cognitive science, on the other hand, would be the interdisciplinary approach to understanding the mind, combining multiple different levels of analysis. And it's called connectionism. So connectionism, it ranged 1980s and 1990s, and the central idea of it is that a large number of simple computational units can achieve intelligent behavior of a network together. So this is like in the biological nervous systems as it does the hidden units in computational models. And in the 1986, David Rumelhart, James McClellan, and the PDP research group published this book volumes titled Parallel Distributed Processing. So the premise that PDP is using here is that traditional computer programs work very differently to the brains. And that might be why computer programs have been, maybe at that point, so bad at doing things that brains find easy, such as recognizing objects in pictures. The author claims that the PDP approach was closer than other frameworks to how the brain works, and therefore it might be better able to handle this kind of task. And we can see here that the term used here is like, they should ring a bell also, because it's very similar to the approach that we have today in our neural net, though there might be some differences. So here, it requires processing unit, you have state of activation, you have output function, the propagation rule, the activation rule, the learning rule. These are all the contexts or the terms that we would hear in today's world. And then in 1986 and 1987, there's Jeff Hinton from the University of Toronto discussing about distributed representation. So distributed representation in a nutshell is that it refers to the idea that each input to a system should be represented by many features, and each feature should be involved in the representation of many possible inputs. And as early as 1986 and 1987, we have David Rumelhart and Jan LeCun showing the successful usage of backpropagation to train deep neural nets. And to couple with that, in the 1990s, Joshua Benjo and Hoytreter showed the limitations of the modeling sequences, and because of that, there will be a birth of the LSTMs, the long short-term memory networks by Hoytreter and Schmidt-Gruber. And of course, the widely known convolutional neural nets is conceived as early as 1998 by Jan LeCun and his colleagues. So, as we think in 1998, we're pretty much set, but why is it that only now, maybe, or some years before, it's just there that AI boomed and we can see these applications everywhere? Well, the reason is this. The first one is ventures based on neural networks and other AI technologies began to make unrealistically ambitious claims while seeking investments when AI research did not fulfill these reasonable expectations. Of course, investors were disappointed. And the next one would be that in theory, the limitation from Rosenblatt's single layer is the solution there is to add more layers. So in theory, that works. But at that time in the 1990s, such networks were often too big and too slow to be useful. And I think we should take note that here it's only in the 1990s, and the state of compute and the technology with regards to the hardware is not that comparable to what we have now. And also, though neural nets and in those times kind of declined, there are other machine learning algorithm that made advances. One is the kernel machines. I think the support vector machines should ring a bell, and the graphical models. So the study of neural nets didn't actually die here. There are still active research for neural nets, though it's not kind of widely spread. So one is in the Canadian Institute for Advanced Research, or CFAR, which may be related to the CFAR dataset, right? So they have this research initiative, and this research initiative is joined by these groups led by Jeffrey Hinton in the University of Toronto, Joshua Benjo in the University of Montreal, and we have Jan LeCun at the New York University. And aside from them, they're also joined by neuroscientists and experts in the computer vision. And now, as we can see in the present, neural networks are now finally living up to their potential. Why? Well, we could use more layers now. I think ResNet 101 is a model that, compared to Rosenblatt's one layer, it has 101 layers. So that's a lot. And that's coupled with the capacity to do so due to the improvements in computer hardware. There's also the increase of data availability, and we can do algorithmic tweaks that allow neural networks to be trained faster and more easily. So it's like 50 years after, but we now have what Rosenblatt promised before: a machine capable of perceiving, it's capable of recognizing and identifying its surroundings without any human training or control. So for the dataset part, I would like to share this one to you. As you can see, as the field goes, there is an increase of the dataset sizes over time. So from the IRIS dataset that is also widely used for introductory courses, and to the ISVRC in 2014. So we can have lots of data right now. Also, coupled with that would be the increasing neural network size over time. Like before what I said, the first one, we have the single layer from Frank Rosenblatt. Then we have now, here in the picture, we have the Google Net. But in the current field, maybe we have 100 layers and more than that, right? So it's pretty amazing. And this would be like my conclusion in this part. Research and advancements in the field are results of a community of people pushing it forward. So it's not a one-man show. I think in those events that we've seen before, it made us respect the field, that what we have now, the activation rule, the layers that we are calling right now. They went from ups and downs. That's why finally we have them in this technology, and that's also must be the reason why we should remember that we should not take this technology for granted, and we should responsibly use it. And it's moving at an unprecedented speed, so it's moving really fast. So because of that, because of the years and because of the contributions of different people, there are many algorithms, there are many ideas. And as a beginner might be, my advice would be try to categorize them so you won't be overwhelmed. And at the same time, it would be organized in your mind. So our next part would be categorizing ML systems. So we'll look at different ways and how we can categorize the systems. So here I would be discussing 4 parts. The first part is that I base it on the amount and type of supervision. The second would be based on whether or not the system can learn incrementally from a stream of incoming data. The third would be based on how the systems generalize, and lastly, based on their applications. So I put here a cute picture of different robots to tell simply how we can categorize these algorithms based on the amount and type of supervision. So it should be 4, but I think semi-supervised is kind of missing in this picture. But yeah, it's very interesting. Like in the supervised, you have the robot saying, they gave me so much to read and test. And then in the unsupervised, you have, me too, but at least they told you the answers. And then in the reinforcement, you have, at least y'all don't make your own book. So let's dig further what those things mean. So first is supervised learning. And the distinguishing factor of supervised learning from them is that the training data includes labels. So when you have this label, like for example, here in the cat and the dog, you would have pictures of the dogs and the cats, and you will also have the labels in the text form saying that's a cat, that's a dog. And these are the example algorithms that I put here. You have the linear regression, logistic, you have the neural nets. And I think one caveat that I should say here is that although they are used in supervised learning, they are not exclusive in supervised learning. I think one is neural nets. You can see it in reinforcement learning and supervised and semi-supervised, but it's also used in supervised learning. So we have here the neural nets, we have the linear regression here on the side, and the ensemble of the random forest. So if supervised learning have labeled data, training data in unsupervised learning is unlabeled. And there are different subdivisions under unsupervised learning. One would be clustering. So as its name suggests, it clusters the data based on some rule. It may be like distance. So some algorithms there would be k-means, you have dbScan, or hierarchical cluster analysis. So here in the picture, you can see that the original and cluster data is like labeled, and then after you have cluster data, you'll be categorizing it to some groups. And then next would be the visualization and dimensionality reduction algorithms, also under unsupervised learning. The algorithms would be like PCA, TSNE, and LLE. And in a nutshell, it's like we human beings cannot understand higher dimensions, like 100 dimensions. We cannot understand that. Maybe we're just limited to 3D and maybe 4D for some. And the job of these algorithms is to have a way to visualize these lots of dimension of the data and to reduce it to some dimension that we can comprehend. So an example would be TSNE here. And last year, I attended ICLR 2020, and I'm very thrilled that a machine learning conference is actually using machine learning, of course, in their website. So you can search the papers, the accepted papers, using, I think this one is TSNE, if I'm not mistaken. So it's like for dots that are close to each other, they may be related, and the dots that are farther uh, to the other ones are not that related. So it's very amazing to see this application. And the next would be anomaly detection, still under unsupervised learning. So how do we deal with anomaly detection? It can be dealt with using the pictures. It can be, on the other hand, we can have data that is like in the rows and in the columns. So the system is shown mostly instances during training. So it learns to recognize them. Then when it sees a new instance, it can tell whether it looks like a normal one or an anomaly. So to further understand this, we have some application examples, like detecting unusual credit card transactions to prevent fraud. We have catching manufacturing defects. And sometimes it is used, the results of the anomaly detection algorithm is used to feed to the other algorithms to remove maybe the outliers. And one related algorithm would be the novelty detection algorithms. So this is kind of different to the anomaly detection. It aims to detect new instances that look different from all instances in the training set. So at first, I'm also confused. What is the difference between anomaly and novelty detection? And we can show that using chihuahuas. Chihuahuas are like loving creatures, and we're just using them as an illustration here. So for novelty detection, it's that even if 1% of chihuahuas are present in the data set, it shouldn't be considered as novelty because there's a representative species. And if we're dealing with anomaly detection, it would be like they are so rare that they can be considered as anomalies. Again, this is for illustration purposes, and we love chihuahuas. So aside from unsupervised learning, we call semi-supervised learning. And it's like a fusion or a combination of supervised and unsupervised. So algorithms here deal with data that's partially labeled. So supervised, it would be labeled, unsupervised would be unlabeled, and semi-supervised would be partially labeled. And most semi-supervised learning algorithms are like combinations of unsupervised and supervised algorithm. An instance would be like you would let the unsupervised algorithm to put labels to the unlabeled data, and from that you feed it to the supervised learning algorithm. Because again, supervised learning algorithm accepts data that has a label. But of course, there are pros and cons in doing that thing. And lastly would be reinforcement learning. So it's like what do we call this? A very different one in the group because algorithms learn by itself in this area. So we can see that this agent right here. So agent can observe the environment and can select and perform actions. So they learn by itself. Maybe here it's learning the parkour or walking. Here it's learning how to play this Atari game well. And of course, AlphaGo learning well the Go. But again, it learns by itself. And it learns by itself via rewards and penalties. So if the agent learns good stuff, it will be rewarded. Otherwise, it will get penalties. And in the if in the previous algorithms or categories we're optimizing maybe the errors, we want to have less errors. Here we're optimizing for the best strategy. The agent must learn by itself to get most reward. So here we want to get the most of the rewards. Yeah, so that's for based on the amount and type of supervision. And the next part would be we can categorize these algorithms based on whether or not the system can learn incrementally from a stream of incoming data. There are only two categories under this one. First would be batch learning. And I think batch learning would be the most pervasive type of learning out there. And what it does is that you have the data, and then you will train the ML algorithm using all of those data, and then you evaluate the solution, and then after that you launch. And maybe while you're monitoring the performance of the model, there are times that you should update the data. And it's also under what we call offline learning. So when we say offline learning, the system is trained and launched into production without learning anymore. So once it's in production, it doesn't learn anymore. And we should learn how to use this also well, because it has its own strengths and limitations. So it's fine for systems, fine with updating the model not too often. Maybe once a week or maybe twice a week. The nature of the data being ingested does not change that often. So the data, as we will be talking later, it has different natures. And it's not good if the system should be able to learn autonomously, because just imagine if the Mars rover, for example, maybe an autonomous or any autonomous system would learn on the fly using this lots of data. Batch learning consumes lots of resources, and also it takes time for you to train those models. So it's not really recommended for autonomous systems. And it's not good if the system should adapt to rapidly changing data. One nature of some data, they really change a lot. They have dynamic trends. One example of that would be stock prices. It changed. The stock prices trends change a lot. And because of that, we have online learning. So it's different from batch learning, because in online learning, initially you have your own full data set, and then you use those data to train the ML algorithm, and then you evaluate and launch. But the different thing is that while it's on production, it will learn. So if there's a new data coming in, it will learn that one. So it's for systems that receive data as a continuous flow and need to adapt to change rapidly or autonomously. And it's also good for systems with limited computing resources. And there's one caution here. A very important hyperparameter in online learning is the learning rate, because if you set the learning rate, it's like the capability of the system to adapt to new data. If you set it too high, then it will rapidly adapt to new data, which might be good, but the thing is that it will also tend to quickly forget the old data. And if you set it too low, then the system will learn slowly, which might be also bad, but it will be less sensitive to noise in new data or to outliers. So if it's not that sensitive, then if you have noise, like it's a very different from the data that we're seeing, it won't learn that much well. But again, the system will learn slowly, and maybe it won't serve your system. So we should be able to take note of the pros and cons and how to handle them well. Because again, no system is perfect. right? And second to the last would be based on how these systems generalize. So there are also two categories under this one. First is that you can categorize these algorithms via instance-based learning. So an example of instance-based learning is k-nearest neighbors. So as you can see here in the animation, it uses the whole data set, and maybe it uses some sort of function, maybe distance. And from that, in this example, as you see, we have 4 triangles here and 3 rectangles in that circle. So we can say that because there are more triangles than the rectangles, maybe it's a triangle. So it kind of works like that. And the next one would be model-based learning. And here we have data again, then it will be trained, and it generalizes by building this model that we have of these examples. And we just use this model to make prediction. So again, the difference would be like in the instance space, it uses the whole data set. It doesn't have model. And of course, in the second part, it uses models. And lastly, based on applications. I think this is also one of the most famous categorizations of ML systems. The first one I would like to share would be computer vision. And it's the area of AI that I'm really excited about. So computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs. And then from that, they take actions or make recommendations based on that information. And I post a Snapchat here of David Scaramuzza's tweet. It's the recent Mars rover event, and I'm really thrilled to see that they use computer vision and to make that thing possible. To be specific, they use computer vision via terrain relative navigation, and he further explained what that one is. It's very exciting to see it in its being applied in the real world. The second one would be natural language processing, called NLP, and speech recognition. These two usually, some people mix them. Of course, sometimes, yeah, it's really hard to identify, but they're different from each other. They have differences. NLP is concerned with giving computers the ability to understand texts and spoken words in much the same way human being can. And in speech recognition, these systems interpret human speech and translate it into text or commands. So to see it applied, we have this here from Google AI. So this video is like about this. The Google AI assistant is booking for a meeting or for a hair salon session in some store. So let's see.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So that's really interesting, right? You can have it on your Google Android phone, and then you can tell that, oh, please book me a meeting to someone. And this another example would be like Ashley Vance, the man that we'll be seeing in this video, is like he recorded his voice and then trained a model that lets this model to output maybe sentences, and then it would sound like him. So you can see here.
My computer voice to the test. I am going to call my dear sweet mother and see if she recognizes me. Hey, Mom.
Hi.
What are you guys up to today?
Well, it's Saturday. We didn't have any electricity early this morning, and we're just hanging around the house.
I'm just finishing up work and waiting for the boys to get home.
Okay.
I think I'm coming down with a virus.
Oh, well, you feel bad, hey?
I was messing around with you. You were talking to a computer.
I felt like I was talking to you. It's amazing.
So yes, it's very amazing technology, and it's getting more of the human features right now. The third one would be recommender systems, and you can see this while maybe viewing or browsing Netflix movies if you're doing that, or maybe if you're shopping. One would be like Amazon. Maybe you have your local stores using it too. So recommender systems, according to Springer, its goal is to generate meaningful recommendations to a collection of users for items or products that might interest them. And the last application I want to share is that about the time series. So this one, maybe it's a different kind of data because you're using most of the data used here would be in the form of rows and columns. So time series is the sequence of observation taken sequentially in time. And maybe with regards to the context of the pandemic, people are using it to see, for example, the predictions of the cases might be. So there we have it, the categorization of ML systems. And though the algorithms are important, there is also one important factor in AI, which will be the data. Data is very important when you're working with AI. So here I want to discuss the types of data that you may encounter. And if we categorize them, you can see them as unstructured data and structured data. So for unstructured data, in simple words, they refer to images, videos, text, audio. So for images and videos, these are like more of what I'm working on. You can see them as in different dimensionality and views. Here you have 2D view, you have the 3D view. It might be images, static one, maybe videos, or maybe you can look at it at an angle. There are also different views. You have the top view. Maybe this is more of the Earth observation applications. And you have the panoramic view. Panoramas are like 360 views, or it can be 180-degree view. And it's like a fish-eyed look. And you can see that maybe this boss looks different because it's kind of distorted because of the fish-eyed view. So you have those. These are some of the instances. And the nature of the data, the images and videos also vary when it comes to the source. So you can have sources from maybe a camera attached on the top of a vehicle. You can have different CCTV, so it has its own nature. You can have images and videos from the medical field, so they have their own nature also, or maybe just a simple like what I'm using now, the web camera. And next would be the different kinds of satellites. So we have different kinds of satellites, and some of the satellites have different camera payloads. And they're not just using what we can see in the Google Earth, where it's like the RGB and the expected views. We can also have infrareds, we can have Sentinel data, we can have maybe the Novastar data. So each of the satellites can give different views. So that's also very interesting. And if you're working with these kinds of data, you should be aware of its nature, of its differences, because it will affect the system. Of course, we have text and audio, and we have different sources. It can be social media, when you can do sentiment analysis. In the Facebook and Twitter, we can have in your emails. You can have archive, lots of research papers. You can record your voice using different kinds of materials. You can also have different sounds, like you have the musical instruments. Of course, just in the field of music, there's a lot of instruments that we can record. And also we have lots of books, of course. Well, we can use it to digitize some of those. And we have lots of papers. So those are kinds of unstructured data that we have, the text and the audio. And when we say structured data, according to Forbes, these are the data that is easiest to search and organize because it is usually contained in rows and columns, and its elements can be mapped into fixed, predefined fields. So I think, in short, you can distinguish this by if the data is contained in rows and columns. So we should put a caveat there that some of the images, I encountered this one in one of my projects. Some of the images are stored as a CSV file. So there are some instances that maybe the unstructured data would be in the form of rows and columns, but it's very rare. And most of the time, the data that you see in rows and columns would be called structured data. So these are like the Excel spreadsheets, you have the CSV files, maybe the data set stored in BigQuery, and those things that you're accessing using MySQL. And when I'm navigating the field, I was trying to look which kind of data is mostly used. I think in the business field, I've seen more of the structured data, though there are some companies in the business field that use the computer vision parts, but it's mostly they use structured data. And for the unstructured data, I think most establishment that use them would be the universities, the research laboratories, and maybe specialized, again, business using these computer vision technologies or maybe NLP. So as we're speaking of data, there's one field right now that is also in trend that is called data science. And I think if you're starting in the field, it's nice to differentiate these two fields as you navigate. So here we will be talking about AI versus data science. And I think it's very useful also to distinguish AI or from data science, because it will set your expectations when you join the company. Because sometimes AI companies is very different from data science company. And as a field, we can distinguish them as like AI ML deal is like in a one bubble, and then data science is a field that intersects with it. And we can see later how data science actually use AI. So for AI organizations, we can differentiate this by what they do. So for AI organization, their main objective is to automate the task to reduce cost or scale production. And then for data science organization, its main objective is to help a firm's leaders make scientific or data-driven decisions to run their business more effectively. So sometimes the line between the differences between these two fields are kind of blurred. And yes, hybrid organizations exist. There are organizations that use AI and data science at once. Maybe an example of that, an example process of that would be AI is giving out the data because you're automating it, and then the results from the AI team would be passed to the data science team, and these data science team would be the one to make sense of the data. So it can work like that, but they still have their differences. They also differ when it comes to the project workflow. So for AI project workflow, you can collect and prepare your data, you train the model, and then you deploy. Whereas in the data science project workflow, yes, you collect and prepare the data, the same with AI, but you analyze the data and suggest hypotheses or actions. And some data scientists use AI to analyze data. I think, for example, the clustering algorithms, you can see they will use it to cluster their data and make sense of it. So that's one instance. They also differ from their output. So AI project, it's mostly the output would be software. Whereas in data science, your output would be actionable insights. It can be in the form of dashboards, or it can be in the form of reports or a PowerPoint presentation. But the main idea is the output would be set of actionable insights. So we're going in the second to the last topic of this talk. And we're done with the AI and data science organizations and the hybrid organization. And now we'll look at what might be the different roles in an AI team. These are the common roles because there are lots of positions when you look in the field, but these are the common. And before I talk about that, I want to tell about the processes, because in this processes there will be people responsible for it, and that would lead to the creation of different roles in an AI team. So this is like in a nutshell. In general, there's data engineering, the process of data engineering. When we say data engineering, people responsible for data engineering, they prepare the data and transform data into formats that other team member can use. The process of modeling is usually after data engineering. So modeling, people assigned to modeling look for patterns in data that can help a company predict outcomes of various decisions, identify business risk and opportunities, or determine cause and effect relationships. Then we have the process of deployment. So deployment, people in charge here take a stream of data, and then you combine it with a model, and then test the integration before putting the model into production. And maybe after this, they do business analysis. So there are team members that are responsible for business analysis. They usually evaluate a deployed model's performance and business value and adjust accordingly to maximize benefit or abandon unproductive models. And in their center would be AI infrastructure. There are also people responsible for AI infrastructure. So what they do is that they build and maintain reliable, fast, secure, and scalable software system to help people working in data engineering, modeling, deployment, and business analysis. So it supports those other processes. So it's very important to have it in an organization. So to look at the roles in those processes, the first one would be the data engineer. And when we say data engineer, mostly the area concerned would be the data engineering. It would be nice to have some background in mathematics, and he should be knowledgeable on AI infrastructure. So the skills would be in software engineering, big data, because again, there's a lot of data coming in. The ETL operations, you would often hear that when we're talking about data engineers. ETL stands for extract, load, and transform. So these are the operations they do in the data. And the common tools, these are just examples of the tools that they're using. So we can have the Python, you have the R, some organizations use R, but I think most organizations use Python. And maybe some use a much lower language like C or C++. And they also use the RDBMS, maybe NoSQL platforms. They also make use of the cloud. Some organizations deliver their services through the cloud. So we have Google Cloud, Microsoft Azure, AWS, and some organization have their services on cloud. Some organizations still have their own systems. Well, I think the reason why other organization decided that is that because of security in some sense, that they want it in their own system only. But I think most business communities use cloud. And you have also the Hadoop, Hive, Docker for dealing with the data. The next common position would be the data analyst. So there are data science organization that sets the position of data analyst as the entry-level position. But in some organization, they have their senior data analyst. So it varies per community. And data analysts, they are mostly they should know mostly of data engineering and business analysis. And some of the tools, you have also Python, the RDBMS stuff, the R, and also data visualization tools. Like Tableau, you have Power BI, Matplotlib, and some tools to manipulate data or to clean data like that. You have an example would be Pandas. So it would be nice here in the figure, you have some sort of data science knowledge, business knowledge, and communication abilities. And I think this position, data scientist, is the most known position in data science. And for some organization, this is like the boss level when you say in the position. But some have junior data scientist positions. So their area would be data engineering, they do data modeling, and to add to that would be business analysis. And as you can see, in data scientists, we also have the Python, the RDBMS, we have the visualization and data manipulation tools. And in addition to that, we have the modeling tools like scikit-learn for classical ML algorithms. For neural nets, we have TensorFlow and PyTorch. And in some organizations, just to share, the data analyst would be the entry position. It will be promoted to data scientist after some year maybe. And we can see that in the tools that they're using. Here in the data analyst, it's just until here data manipulation, the business, and the data visualization side. While in the data scientist, the modeling part is added. There's also people called machine learning engineer. And the area would be data engineering, modeling, and deployment. So you can see ML engineers and AI organization most of the time. And some organization only have ML engineers in their company. But then these ML engineers can have further specialization, like they're only specialized in data engineering. Some are responsible for modeling, some others for deployment. So there are things like that. And the tools that would be added would be the cloud, or maybe the company is working using edge devices, or it will be deployed in edge devices. There are companies that does that too. Next would be ML researcher. So if ML engineers have, let's go back, data engineering, modeling, deployment, machine learning researchers is more of data engineering, modeling, and research. And that's why I included here some of the known conferences. These are like the top tier conferences, but of course there are other conferences. So you have NeurIPS, we have ICLR, ICML, and some sources where we can get updates from the maybe state-of-the-art research or models. We have Archive, Twitter, yes, and Reddit. So here, in my experience, I follow people like known people on Twitter and Reddit and join the discussion in Twitter and Reddit. And those are just the general position. There are many positions that you can see when you look at LinkedIn or some job posts. They sometimes call it different names, but you have to look at the job description, what it really does. And sometimes the ML research, for example, ML researcher, it's disguised under the position software engineer. So you just have to dig it if you're looking for jobs. Sometimes we have specialists like computer vision engineer researcher, have NLP engineer researcher, AI engineer, until to the geospatial analyst and business analyst. And just to share in our organization, I think the data engineers would be the people who knows more of geospatial data. So they are the geodetic folks. They know how to handle the data. They know how to collect the data. So it's more of a specialized position. And here we're nearing the end of the talk, I think just in time. So we have those different positions as a career path, but the question would be, where do we position humans in the age of AI, the general or all of the humans? Well, according to Carl Wegener, this is like most of the issue that we're facing. A majority of people think that AI will steal their jobs away from human workers. Well, they're not wrong, but that's not the whole story. So unemployment is one of the issues here, but that's not the whole story yet. And this is one of the TED Talk from Kai Foley, and I'm really glad to share it with you. So there's an axis here. So as we go left, this leads to the job, more of the jobs that needs to be optimized. And as we go to the right, these are the jobs that needs more of creativity and strategy. And we have repetitive jobs, we have routine jobs, optimizing jobs, still the creatives. And according to him, in 5 to 10, 15 years, this tree will be replaced by AI. So you can say that, isn't that a sad thing or what? But let's hear from him that as AI takes away the routine jobs, I think the key word there is routine jobs. I think that we can and we should and we must create jobs of compassion. So though AI takes away jobs, it also creates lots of jobs. And I think there's a statistic there that shows that though AI makes other job like it's been phased out, it creates more jobs than that. And this is one of the realities in the workplace, that AI is changing the workplace. It's not, again, in the future, but it's already happening now, as we can see. And to further to add to the access before, just to show, to understand this, we have an access before for jobs going to need optimization here in the left. And as we go right, these will be the jobs that needs creativity or strategy. And as we go to the top, we have jobs needing compassion. And to the bottom, jobs where compassion is not needed. So from that, we will try to map out the ways how we people can work with AI. So this will be the last part of the talk, the blueprint of the coexistence of humans and AI. So where do we stand? So the first way we can, AI will affect us would be AI taking the routine jobs. So it will be replacing these jobs as a whole. And for other jobs, as you can see, for example here, the research analyst, the scientist, the artist, they're under the category of AI as a great tool for the creatives. Maybe some of them would be replaced by AI, but some would let AI be another tool for them to use. And next is AI will work with humans as analytical tools that humans can wrap their warmth around for the high compassion jobs. So the jobs here, just looking back, these are the wedding planners, the teacher, the beauty consultant, the homeschool teacher. So we can see that it's still very human, but at the core there will be the use of AI. And lastly, there are jobs like the CEO, the social workers, the PR marketing directors, these jobs that require compassion and lots of creativity and strategy. Here we can always differentiate ourselves with the uniquely capable jobs that are both compassionate and creative. So using and leveraging our irreplaceable brains and hearts. So there will be jobs that lots of human and a little of AI. And this would be, I would gladly share this quote from Kai Fu Lee. He said that AI is serendipity. It is here to liberate us from routine jobs, and it is here to remind us what it is that makes us human. And yeah, as we go in the field, I hope that this talk showed the different ways or different parts that you might be encountering, even if you're planning to make AI your career path or not. And yes, I think I would end my talk here. Thank you so much for listening.
Thank you so much, ma'am, for introducing us to this amazing universe of ML and AI. Hopefully, our participants must have got some interesting knowledge on this topic.
Thank you.
I love the way you said that we should respect the field we are working for, as they give us so much interesting knowledge in the vast technicalities according to the concept. It was great talking to you. So let's move on to the quiz. So, guys, it's quiz time. Buckle up because you have got 15 minutes to attempt the quiz, the link for which you can access in the YouTube live chat box. Give your best, which will help you to collect the badges for maintaining your rank in the leaderboard. So I would explain you again about the badge system. So after every introductory session on each day, short quizzes on the respective theme will be floated on the Discord server, which holds 30 points each. Make sure you try and ace these simple quizzes. After each hand-on workshop scheduled on day 2, a project task will be put on each track on the same server, on completing of which each participant can earn 50 points. Don't let this grand bonus slip out. Lastly, on day 3, each track panel discussion, another questionnaire will be sent out to you all to fill. This activity will hold 20 points each. Ponder upon the talk of the panelist and make sure you come up with the best answer list. All the participants will be provided with customized and certificate badges on the basis of their score by the end of day 3. So participants who score 90 plus point will be awarded a bronze badge for his or her efforts. Those with a score ranging from 180 to 270 points can affirm for themselves a shimmery silver badge. Lastly, anyone with 270 plus points will be given the highest level and the most shiniest, the golden badge. The leaderboard will be maintained for each day, and the top 3 performer at the end of day 3 will not only be showered with badges and certificate but also with exciting goodies. So guys, start collecting the points now and don't miss these activities. I guess the link has been given in the chat box. Yes. Start attempting, guys. I guess all can earn all 30 points today according to the session.
So participants, hopefully you all have attempted the quiz. And now we will be beginning with a short question and answer session with ma'am. So if you guys have any doubts or questions regarding the topic, feel free to comment down your queries in the chat box. Okay, so there's a question. And Anagha, can you read it out?
Yeah, ma'am, this is asked by Mitesh. Is there any yeah, just a second.
Okay, should I answer it now?
Okay, so the question is from Sanket. Which country will be good if I want to do my MS in the field of AI?
Oh, that's an interesting question. With regards to the countries, I think each country has different uh, specializations. I think when you're going to pick a university, you should pick universities based on your specializations. Like maybe Oxford is more of specialized in medical sciences, and some universities are specialized in space sciences. So I think you have to consider that. And I think if I would list my top three countries, would be first would be Canada. I think, of course, we have the three touring awardees there: Geoff Hinton, Yosha Benjo and Yan LeCun. And I think US can be great also, and UK. But yeah, you should when picking MS degrees, you should not just consider the ranking of the school. Sometimes they have their own specialization, and try to match it with your interests. It's not because they're top one that they're going to match their interests. So yeah.
Yeah, Sanket, I hope you got your answer. Next question. Okay, it's from Swappy. How can we coexist with machine that inherently lack human values?
How can we coexist with machines that inherently lack human values? I think this is like it's like a philosophical question in as I'm interpreting it, because it's talking about the machines that inherently lack human values, and I think it's more of philosophical question that can machines have human values in the first place, right? But how can we coexist? I think we can simplify this question as we should take note of the system's strengths and limitation, what it's functioning, what it's doing well, and where in some places it's not doing well. And for that, and from that, we can, I think, leverage what it can do and be careful of the things that it might not do well. Yeah.
Okay, it's the next question is from Janak. How can someone start its learning process in NLP? What are the prerequisites for it?
In the field of the NLP, I think I may give you an answer because I'm more on computer vision, but for NLP, I think it's more of the general. You should know how to program first, of course, and you can go into two paths. You can do the implementation one and or the theoretical one. I think my advice would be for you to go to the implementation of one. Try to implement, try to see it for yourself. How does this work? What are the things that what it can do? And then from that, you can map out your maybe your own self-study curriculum, how to do this step by step. So I think the first one, you should know programming at some point.
Okay, so our next question is, Omdev, we are rapidly developing towards finding life on other planet, looking at the telescopic data and stuff, right? So is there any way we as civilians can contribute towards that goal?
Oh, that's an interesting question.
Mm.
I think I can interpret the civilians as those people working in the field, but it's more of the context and Earth, maybe. So I think technology is very transferable, and there might be some just adjustments when you will use it outside or to the other planets. But I think some of the technologies that they use, I think the example here would be the Mars rover. They tested the other capabilities in some part of the Earth that is similar that of Mars. So as we researchers, the applications that we're doing here in the Earth, some of it can be easily transferable for planet explorations.
Okay, so next is from Nandita. Can algorithm take human content into account?
Can algorithms take human context into account? I think that would happen if the humans who made those algorithms let the algorithms take you into account, right? I mean, like NLP, the field again is like understanding human text, right? So in that sense, you can.
Next question.
From
Ma'am, let's finally sort out this debate on ML versus data science.
Oh, I think it will be long if there's a debate, but to put it short, I think there are differences. Again, AI and data science have differences, but uh, there are also similarities that they can work together. It's not a field that it's like enemies of each other, right? So they can coexist with one another, and they can also do their own thing. So I think that sets us up.
Okay, so this question is like, how can we control data about ourselves in respect of privacy that is issued by AI? As AI will learn and like have almost all of its own thinking, and hiding will be hard. So yeah.
Yes, I understand the concern of this question, right? And it's a very active research field in AI. We have the privacy in AI, and one thing as I've seen is that they try to encrypt. I mean, if it comes to their privacy, they try to encrypt the data in some sense when they fill it to the model. But again, it's a very active research area.
Okay. So can we process more that 4 dimension using complex algorithms? Also, can we make AI that lives in higher dimensions? Okay.
Definitely, there are data for images. You can have RGB, which is like, I think in that sense you have 3 channels if you can relate that to dimensions, and there are RGBD, which concerns of the depth. So there are algorithms that does that. And of course, when you're dealing with rows and columns, there will be a lot of features, and again, that will be considered as lots of dimensions, right?
Yes. Okay, so what kind of unexpected failures might occur in a world built upon AI? Interesting.
Oh yes, this is very interesting. And just to make a comment on it, when you're dealing with ML systems, I think this is from one book, Machine Learning Engineering by Andrei Vorkov, and Casey said there that hoping that there will be no uh, uh, failures or some things that won't go well is not a good strategy. So yes, there will be failures, and you should know how to handle it well. So what kind of unexpected failures? Uh, there may be there's a lot depending on which system. Maybe an example would be if you're dealing with online system. Again, they are system that continually feeds on incoming data. If your new data is like noise or an outlier and it's in the system, then your client might notice that, oh, the system learned on that new data that it shouldn't learn. So in that sense, the developer should know that and should monitor that. That's also one part of the system, and take the actions.
Right. Okay, next question. Considering the current scenario in IT sector regarding employing freshers in companies, how important or useful is it to learn AI or ML? Or is it still weighing towards research section?
Mm. According employee freshers and companies, how important. I think learning another skill is always an advantage, right? And it depends if it's going to be that advantage or a little advantage. It depends on the type of the job, and better to look at the job description again. Sometimes they have preferably no AI ML, so you might take that jump. And the second question is, or is it still weighing towards research sector? I think it started as a research discipline, but now we know that there are many companies out there that does AI. And again, it's very helpful to add AI in your skill set.
Okay, so the next question. What missiling data sets are holding back our human potential?
What missing data sets are holding back? What do you mean about this question? What missing data sets are holding back our human potential? Oh, I think I can interpret this as what may be the other data that we don't have yet, right? That might be another way of pushing the field. I think, as Andrew said before, that AI is the new electricity, and there's a lot of field that it will change. And I think some areas like maybe uh, in the sciences, there are fields that doesn't have that data set ready for AI. I think that is very important to note that ready for AI, because it's not just there's a bunch of data sets and it will necessarily lead to an AI product, right? It should be usable for an AI application. So there are still some fields in the sciences that doesn't adapt much, but I think we've seen some applications steadily arising, and we should hope for more of this data sets coming in.
Yes, yes, definitely. Okay, so any examples how AI or ML is being used in astronomy?
Oh, this is interesting. In astronomy, maybe you can have different kinds of data again. You can inject it on satellites. Maybe satellites have these star trackers. So they use the stars to position themselves, right? So
Yeah.
we can inject that there. And maybe on the data itself, like the black hole image, right? They use computer vision or image processing to generate that image. So it can be in the data from the satellite. It can be also on the data captured by the satellite, right?
Okay, so any pro tip for aspiring data scientists and AI engineers?
Oh, bro. Oh, okay. If there's one thing that I would tell my younger self is that don't skip the fundamentals. Don't skip the basics. I mean, it's okay to dive into the applications, but then don't stay there. Try to dig in. How does it work, right? And try to write your code and try to project. So don't skip the fundamentals. It will help you a lot. A strong fundamental will lead you to better understanding of the advanced parts.
Sure. Okay, so we come to an end to the question and answer session. Hopefully, all your doubts and queries are cleared. Thank you, ma'am. We'll like to have thank you heartfully that you took out your valuable time and addressed our participants. And thank you for your cooperation on being a part of Epsilon 2021.
Yes, ma'am. Thank you for being such a great. Thank you for being such a great audience. We wish you all the luck for your upcoming endeavors and hope to see you in our next session of Epsilon 2021.
It's my pleasure as well. Thank you.
Thank